All right. Good evening, students. How you doing?
Good evening.
Hello. How you doing tonight?
I'm great. How are you?
I'm pretty good. I'm hanging in there. So just I was thinking about 1 week is Mardi Gras, so maybe that's why I noticed that everybody seems kind of at school today. I think it's traditional that the week before people get kind of, I don't know, thinking about getting a break. All right, and I got a little note on the board. Look through that a bit because I wanted to make sure people understand the key to passing the 120. All right, that it's the tests. Okay, and for each one of the tests and the 2 exams, there's a little associated review. So you want to use that to make sure you're ready.
Okay.
And it's not just this class, but traditionally, if a student doesn't do well on the test, they think, "Oh no, let me go back and start from the beginning and do stuff that I wasn't able to keep up with." Well, that's very hard to do because Alex never forgets anything. Alex keeps track of everything you've already mastered, even the things you mastered. It'll keep bringing them up to you. But all of that past stuff is just 10%. Almost everything else comes from the test grades. And I like to make sure that there's a review vehicle in there for each one of the tests and exams. So please use those because I've seen people when they use those, even if they can't keep up. I had one lady last semester, she got so upset with the Alex stuff that she just started doing the reviews and she was able to pull off a really nice grade in the class. All right.
Hello,
Anybody got
Mr.
any
Cruz.
questions? Hello. How you doing tonight?
I'm good. It's Tuesday.
Yeah, I know. This is a hard task for me to get through on Tuesday because it's kind of like sort of like my hump day, and this
Yep.
is like going all uphill.
Gotcha.
So, anybody got any specific questions? As I said, we're going to get started on chapter 3 tonight, and I'm going to give you a little preview here, and kind of address the little topics more thoroughly that we would be able to do in the regular class. So that way we kind of overlap and cover things twice. All right, so let's look at the textbook here. For the 020, when I kind of cover up, I kind of double up on stuff. Like I said, I'm going to go over some key things to help you understand what's going on in this chapter. And I'm going to use the textbook, and then the textbook I can kind of use the annotator to write on here. And I think that'll be a good way to show you. And then in the 120 lecture portion, I'll use my. All right, so logic. Basically, logic is being able to use these principles we're going to learn to build a sound or valid argument. Okay. And you might not think that's important because we're not just talking an argument with somebody, that kind of thing. What we're talking about is building an argument that will stand up logically. And that's what all the computer stuff is based upon. That's what all of your English class is based upon. If you have a logical argument in both sides, in the math side and the language side, like English, then you've got power. You've got a strong base on which to build things. All right, so let's look at these things called statements and quantifiers. All right, I've got this thing underlined here. A statement is a declarative sentence that can be objectively determined to be either true or false, but not both. In other words, it can't be what we call a paradox, It's got to be something and we'll see in a minute examples. But it's very much like, if I click on this, you see this little note that comes up, very similar to the idea of the well-defined set in chapter 2. As a matter of fact, all these things relate back to chapter 2. It's just that you're kind of looking at them from a different vantage point. Okay. All right, so let's look at some things that are statements. All right, so I'm just going to take you through theirs, and then we'll look at a couple of you try it things. Now, they're going to give us several statements, like most scientists agree that global warming is a threat to the environment. Doesn't matter if it's true or false. Is that your laptop? Question mark. Man, that hurts. D is 432 plus 8 divided by 1.3. It says it's equal to the square root of 1,115. This book is about database management, and F, reality shows turns your brain to mush. Okay. So what they're telling us here is that A D and E are statements. So A, most scientists agree that global warming is a threat to the environment. True or false? I'm not going to get into that, but you get the idea. It's not both. It's one or the other. Okay. Is that, let's see, D is a statement. It's a mathematical statement. They're telling you that this operation, 432, plus 8. Oops, you know what? I got to back up here. We got to do order of operation. What comes first? Addition, subtraction, multiplication, and division. It's 8 divided by 1.3. So that's got to be done first. And then we're going to add the 452 or 32. And that gives us that 332. Now, I can find out if it comes out close to this by just squaring it. And it looks like it sure enough is. So it doesn't matter whether it's true or false. That was close enough to convince me that this is intended to be a true statement. But we can check that. We can objectively check it and find out if it's true. And E, this book is about database management. Well, it's a false statement because this is about contemporary mathematics. Reality shows turn your brain to mush is a false statement. I mean, it's not a false or true. It's, an opinion. Now, if there was some kind of consensus out there from studies that it did that, then yeah, it could be either true or false. But it's got a euphemism in there, turn brain to mush. Well, that just kind of doesn't happen from watching too much TV. It might do something to your brain. It might atrophy it where you can't think very well, or if you just accept opinions off of TV as truth, then in a sense, you could say it's turning your brains to mush in a very symbolic way, but it doesn't actually change brain to mush. It's not like a flesh-eating zombie. Okay, so let's look at some here. And so we've got A is those pants rock. Notice that exclamation mark. 12 minus 8 is equal to 5. Give me a bottle of anything and a glazed donut to go. Cat can send picture messages with her cell phone. when does the party start, and history is interesting. All right, what do you think about A? Is that a statement?
Yes.
Yes.
Why do you think it's a statement? First of all, is it true or is it false? This is why it's important to be able to know that. Is this true or false?
False, because it's just an opinion.
Well, that's it. And what do we say about opinions up here?
What did we say?
Yeah, what did we say up here about opinions? It's not a statement because it requires an opinion. Now, again, it's not very well defined. And also, this is your clue right there that it's got an exclamation mark. Okay, and what we said up here, exclamations and questions are not statements. How about this one here? 12 minus 8 is equal to 5.
All right, that one true.
That one's what?
That one true, right? You said the answer don't have to be correct, but
But we're not saying whether it's true. As a matter of fact, this is false, isn't it?
yeah.
12 minus 8 is 4. But does that matter to be being a
No.
statement? No, it doesn't matter. It's just as long as it's either one. So B is a statement. How about C? Give me a bottle of anything and a glazed donut to go. Is
That's
that
a
something
state.
that's true or false?
True.
How do you know that's true?
Is they're actually asking for something specific?
But you got to say is who is this talking about? Again, it's basically a command. All right? There is no truth value to that. How about D? Cat can send pictures, messages with her cell phone. It sounds absurd. You think it's true or false?
True.
So you think there's a cat that can send pictures with messages with a cell
No.
phone? See,
No, that
that's
would
the
be
point. It
funny.
does not matter if it's something that's absurd in the sense that it's obviously a false statement. That's a statement. When does the party start? See, there's your hint right there.
False.
It's not just false. It's what we're asking is which
True.
ones are
It's
statements.
true.
This is not a what?
It's not a statement.
Statement.
It's not a statement. That's
So
all we're asking because it's a question. A statement makes some kind of declarative, objective string of events, I guess you would say. So this is a question, so not. What about history is interesting?
Opinion.
It's an opinion. If it's an opinion, then it harkens back to this about turning your brain to mush. Okay. If you were to say something like history is the study of the past, then yeah, that would be a statement. But now it's just an opinion. All right. Now, so if we got simple statements, then in order to build our argument, we got to use these things called connectives. And these go back to what we looked at in chapter 2. You remember we had the union and the intersection, those couple of things? Well, with statements, we put them together with the and the or. So the and here is called the conjunction. Over in chapter 2, they called it the intersection, but it meant the same thing. And And then we got the disjunction, which is or, and or related back to union. Okay. And then we got these other two ones called the conditional. It's if then and if and only if. So here's a couple of some statements that are called compound statements, and they use these connectives. So John studied for 5 hours, and that's either a true or false statement, and he got an A. So two statements put together with an and, which is called the conjunction here. I'm going to pass this class, or I'm going to change my major. Or, so this is a disjunction. So conditionals, if I get 80% of the questions on the LSAT right, then I will get into law school. So the way the conditional works, they give you a condition here upon which this will happen. In other words, going to law school is dependent upon getting 80% of the questions right. And if and only if is kind of a strange bird. It's just basically a fancy way of saying that if two things are it's talking about equivalences. But we will win the game if and only if we score more points than the other team. So both of those things go hand in hand. Scoring more points than the other team is essentially the same thing as winning the game. So these are what we call a biconditional, it's called. If and only if. So just to say what's simple and compound, and if you started your, if you've already gotten to the 3.1 Alex, you've probably seen these. So our school mascot is a moose. If you register for Wi-Fi service, you will get 3 days of free access. Tomorrow is the last day to register for classes. In the interest of saving the planet, I plan to buy either a hybrid or a motorcycle. So is A simple or a compound? And the way you determine that is just look, do you see an and, an or, an if then, or an if and only if in there? You see an and in here? Is there an or in that first one? Nope. And there's no if then, and there's no if and only if. So this is what we call a simple statement. See that? Simple statement. If you register for Wi-Fi service, then you will get 3 days of free access. So this is what we call a conditional statement. And though that's a conditional statement, it's compound because it uses one of the 4 connectives. Tomorrow is the last day to register for classes. Simple or compound? Hint, 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 hint.
Simple.
Yeah, simple. It doesn't have an and, an or, an if then, if and only if. In the interest of saving the planet, I plan to buy either a hybrid or a motorcycle. Now, the first part is not really important, okay? Because what the statement is I plan to buy either a hybrid or I plan to buy a motorcycle. Okay, so this is a compound statement. It's a disjunction because it's got an or in there. Because this is the part that matters. He's going to do 2 things. So let's look at these without the helps. My jacket is both warm and light. You see an and, an or in A? There's an and in there, and it's basically saying my jacket jacket is warm and my jacket is light. But the way they write it like this, the both and the and kind of intonate that they're talking about the same thing. B, there's no and or in it. There's no if then, if and only if. So this is just a simple statement. But here, right here, what is C? If it does not rain tomorrow, I'm going windsurfing. So the windsurfing is contingent upon no rain. So this is a conditional statement. It's compound. I'm going to eat at Taco Bell or Wendy's today. Again, it's basically saying I'm going to eat at Taco Bell or I'm going to eat at Wendy's today. So there's an or in there, so it's a compound. And E, yesterday was the deadline to withdraw from a class, an or, so it's simple. All right, we don't mess with quantified statements in Alex, so I'm not gonna mess with that.
What? What are you attacking?
All right, let's look at this thing called negations, the negation of a statement. The negation of a statement is just basically putting a word in there that gives the opposite meaning. So if we have the statement, Auburn will win Saturday, then the opposite or the negation is Auburn will not win Saturday. Statement, I took a shower today. Well, the negation is I did not take a shower today. If the statement is my car is clean, then my car is not clean would be the negation. You don't negate by changing like this Saturday to Sunday. It's got to be the same like day or same item you're talking about. Like here, you wouldn't change it to bath. It's got to be shower. It's got to be the car that's clean. So, all right. So that's the quantified ones. So here's the breakdown and just summary of the connectors. The and, since this is what we call symbolic logic, then that's what we got to use right there for and. Okay. So in place of the word and, when we translate sentences, then that right there is going to take the place of and. The or looks like the V. Now, I should have said up here, the and looks sort of like an A without the line through it, if that helps you remember it. But the interesting thing about it, and let me annotate here for just a second. Over in chapter 2, as I said, you had the union and you had the intersection. However, kind of squiggly those are. Hopefully you remember those. The intersection, it's rounded at the top. But here's the thing is, some logic textbooks use these two symbols over here. So that's why it's it's not so much the shape, it's the upside downness or the sitting on the bottom one kind of thing. See, or was the union, the U, which is the same thing as the disjunction. And the and is the caret thing, usually over the 6 on your keyboard, and that corresponds to the intersection. All right, let's see. Okay, so what we want to do here is just write some symbols symbolically. In other words, if we define P and Q, what they are as letters to go with those statements, in place of those statements, then we can use these symbols, the and, the or, the if then, if and only if, to write things out completely symbolically. And then we can use some logic, some tests, I guess you would say, to find out whether we have a valid argument. That's the end goal. Okay, so let's look. So I'll show you this, and then we'll look at the ones down there that don't have the hints on it. So they want us to write the negation of these. Let P represent the statement it is cloudy, and Q represent I will go to the beach. Okay. So I will not go to the beach because P is I will go to the beach. Whoops. Q is I will go to the beach. So then this is not Q. So this right here that one right there would be written symbolically like this, not Q. And if I hadn't told you this right here, let me write this out. This is the symbol for negation. It's the little tilde thing. It's up there, right top pinky, left-hand side almost, right below the escape. So then this right here, negation sign Q, if Q is I will go to the beach, then this right here represents I will not go to the beach. If it is cloudy, and that was cloudy is P, right? And Q is to the beach. So if P, then Q. Oh, I'm sorry. Wait. I'm looking at I mixed up two. This is the B. It is cloudy, and I will go to the beach. Okay. It is cloudy, and I will go to the beach. So the and is the little thing that's like that, the little hat thing sitting on its legs. So that's that, P and Q. Now, here's the conditional. If it is cloudy, if P, then I will not Q. So that's that one right there. P arrow, not Q. So everything is being suppressed, is being represented symbolically now. Once we define the P and the Q, what they are, we can write a whole statement or a compound statement symbolically. All right, and so the last one is I will go to the beach if and only if it is not cloudy. So this was B, and this would be, I'm sorry, it's P as it is cloudy, and Q is the beach. So I will go to the beach. I will go to Q if and only if it is not P. Well, go to the beach. I think they got it wrong there, don't they? P. So it's not cloudy. Cloudy is P. So this one's backwards. So this would be Q. So that's what it should be because they've got them backwards here. All right, let's do these ones here. So here's the definitions right here. P is I will buy a Coke. Q is I will buy some popcorn. Okay. So now we're going to, instead of writing out these, we're going to change the appropriate letter here and use the symbol for and, or, and so forth. So on this one, it's going to be, I will buy a Coke. So that's P. The and, I'm going to have to draw that in. Oh, that's right. It's up here. I will buy some popcorn. Okay. Is that correct? Does that look good? Y'all alive out there?
Well, I'm still alive.
All
We're
right.
good.
All right. I will buy a Coke and I will buy some popcorn. And again, I'm going to go over this with my, through my using my notes in the next part too. I just wanted to have tonight be give you an extra little bit of practice at this. All right. I will not buy a Coke. So Coke is P. So it's not P. So that whole thing, because once we've identified what P is, we can write it as negation P, which means I will not buy a Coke. If I buy some popcorn, now that's Q. Then I will buy some Coke, which is P. Okay. I will not buy a Coke. I will buy some popcorn. I will not buy a Coke, so that's not P and Q. All right. So anybody see any problems with any of these or questions?
So far, it looks good.
Okay.
Looks easy. So far.
Well, that's why I'm trying to make it. So all we're doing is representing symbolically. And this is going to be useful later because very much like in chapter 2, where we built up to doing those survey problems. Well, it's very much like that, except what we're doing is we're going to find out whether an argument is valid, and we got to translate symbolically. Because when you're doing this to find out if it's valid, you don't want to get bogged down in the actual emotional attachment to words. You want to find out if the structure of this argument is valid. And then once you got that, then you can place your your P and your Q or whatever with actual statements. All right. So now let's go to let's go the other way now. Let's go back, and I'm keeping that up there. Okay. So if P is my dog is a golden retriever and Q is my dog is fuzzy, then let's see, that would be My dog is not a golden retriever. Okay, because P is my dog is a golden retriever. There's a negation built into it. So that means then this is the translation of that. P or Q. So my dog is a golden retriever, or my dog is fuzzy. Okay, so all I'm doing is using my P, my Q, the definition of them there, along with this symbol, the or, the if then, the if and only if, and the and. I'm replacing them now with the words. All right, so let's go and do this one. What would this one be? First of all, what's the connective? What's putting those two things together? What does that arrow mean? So not P, and the arrow means if then. All right, what is that one right there in the middle, that double arrow? My dog is fuzzy if and only if my dog is a golden retriever. The last one is an and starting with the Q. So see, we can go back or forth to translation from symbols to compound statements. We just simply need to know what P and Q are. Those are going to be defined for you in the Alex. They do that for you. All right, let's see what else I can get up to. Oops.
I have a question.
Sure, go
So
ahead.
you say we only need to know P and Q, so down the line with the letters change and it means something different.
Oh, it'll be P, Q, and R is the most you'll ever see. And the R is kind of rare. So it's usually P and Q, meaning there's two statements in almost all of the situations that you got.
Okay.
Let me erase all this. All right. Let's see what else we can get up to. Man, we still got half an hour. All right. Quantified statements. Okay. Let's talk about truth tables. Now, this is the thing that that's a parallel to doing the set operations and chapter 2, you know, we have A union B complement is in union with the complement of C, that kind of thing. Well, it's the same thing here. That's what the truth table is. It's the corresponding way to find out what these things are equal to. That's what a truth table is. It's sort of like a set operation. So you do the exact same thing. You start with the most complicated parts on the inside, and then you work your way out. Now, the simplest ones of these, it's not a connective, it's the negation. It's just it's an operative because it'll only work on it's designed to work on one statement at a time. All right. It doesn't need two like the conjunction, and you need to have two parts to it. For or, you got to have two parts to it. For if then and if and only if, you got to have two parts to it. But negation, as we saw, is you can just negate a simple statement. All right. So this is what we call the truth table for it, or the basic truth table, because this is what happens. If that statement that we're looking at is true, then when we take the negation of it, it becomes false. But if it's false, when we start out with it, we negate, it becomes true. Now this happens to line up with us. So if P is today is Tuesday, which is true, then the negation today is not Tuesday is false. So let's just change it to Monday, because we're not definitely not Monday. If we say today is Monday, then that's a false statement. So the negation today is not Monday is true. So that's what happens when you negate a statement. You just take the opposite of true or false. In other words, if it's true, it becomes false. If it's false, it becomes true. Let me erase this thing. It's hanging around too much. Okay. So the conjunction, and this is going to go back, and I'll show you this over in the Math 120 lecture. Let's see. Do I already have them open? Those notes? No, I don't. I'm not going to chase after them right now. I'll show you this, but I'll just tell you. This relates back to the idea of the intersection, and you can even, as we'll see in the notes, the Venn diagram lines up with this. Okay. In other words, the Venn diagram, remember, for the intersection, if it was in both, that's what we call the intersection. Well, it's the same thing here. There's four possible values when you're talking about two statements. Either both statements, individual statements, are true. The first one is true, the second one is false, first one is false, the second one is true, or they're both false. Now, remember how restrictive the intersection is. It's only where they're both. Well, here's the corresponding idea. If they're both true, the conjunction compound statement is true. But any other case, in other words, all you got to do is have false in there one time, and the entire statement is false. Because when you say and, it means you got a very high bar there of both being true. And this uses the example of I bought if P is I bought a laptop and Q is I bought an iPad, then with and in there, you got to do both for that compound statement to be true. If you switch it to or, and I think they left this out. That's supposed to be a T there. They're making me chase down all the mistakes. All right. So now, like how it is with or, remember the union? It could be in one of the three, but the outside of the union is when you're not in that union, of course, the neither nor. That's why all you got to do is just be a true in either P or Q, and the entire statement is true. And the only time it fails and becomes false is if neither one of those were done. And this is a bit, some of the basics of computering, because what they call computer architecture, everything is built with these like little gates. Not, and they will be built physically, but it's got to be done kind of electronically first before it can be built to be a computer. All those little things that are inside of the computer, they actually have a little, I don't know what you call it, a resistor or a die. Those little things represent these things, and they do these functions. All right. Now, here's the thing about the conditional we got to watch out. The conditional has two parts, and we got to be wary of this one because, as I had said before, when we looked at, let's highlight this. If the Cubs win tomorrow, they make the playoffs. So making the playoffs is conditioned upon winning tomorrow. So the way the conditional truth table works out is you got three, well, it's like the or, and then you got three truths. Now let's go down here and bear the suspense. But the only time that is false is here. And this is because order matters. Because if the condition is met and the consequent doesn't come, in other words, it's false, then the entire statement is false. Otherwise, any order of P and Q, true and false, gives you a true statement compound when you're talking about the conditional. And then the biconditional, like I said, this has to do with equivalence. So if they're the same, in other words, if you got two truths, then the compound statement is true. And if you got two falses, because the biconditional is simply can be expressed in this second way, which is equivalence. And when they're false is if they don't match. They don't match. So here's the thing summed up. And what I would ask you or recommend you do, I have these in my notes too, and you can use whichever one you want. You could just maybe take a picture of this and have it on your phone. So as you're working over the next 2 weeks before, we got about 2 weeks to the next test, you can just kind of take a look at that until you get yourself, I guess you would say, weaned off it, because you eventually want these. So for the midterm, you're not going to have any kind of helps in there. So these are things you got to make sure you understand the difference between. See that? And has this configuration. In other words, it's only true when both statements are true. The disjunction is true as long as there's one T in there, at least. And false only when there's two falses. The conditional is the one, as I said, it's dependent on order. The order, 3 out of 4 times it's true, but the one here, true, false, in that order, is false. And the biconditional, like I said, is if they're the same, it's true. If they're different, it's false. And the negation is just the opposite. Uh-oh. What happened? All right. So I must be like coming down with something. Oops. There we go. So let's look at just building a truth table. All right. So that generally what they show you here is if you follow this, and Alex will pretty much just force you to do it, is you follow this standard pattern where you got for your two statements, P and Q, you've got 4 rows. And then for the P column, there's 2 trues and then 2 falses. And then the Q is true, false, true, false. And what that does is it gives you all the possible combinations of these two things: true, 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 false, false, true, and false, false. So that's the order that most people follow. If you don't, it kind of makes it hard to line them up. So let's see how I can do this, because I want some room here. All right. So let's see if I can. All right. So we're going to do P or not Q. So I want to build. I think it was not Q, wasn't it? P or not Q. Good. So then I'm just going to do it on here. Because I can't open the book at the same time. It disappears when I'm on here. And there's not enough room on that page. Okay. So what I do is, and you don't have to worry about actually building it like this, but build a little table here. Alex has got all this built in for you. All right. So this is going to be P. All right. And as I had said before, we're going to do true, true, false, false. And then this is true, false, true, false. All right. So just like with the set operations, I want to start with the part that's the most complicated. P, I've already got here. I'll wait to know what P is. But what I don't have is I don't have not Q. So I'm going to put not Q here. That's probably not a good not Q, but I'll try it again. Make it look like that Q. All right. Still not the best, but we got the idea. So the negation is just the opposite. So I'm going to take the opposite of all of these 4. So the opposite of true is false. The opposite of false is true. The opposite of true is false. And the opposite of false is true. So instead of true, false, the opposite is false, true. Now, just for the sake of, I guess you would say, clarity. All right, we don't need that Q anymore, so I'm going to kind of block it out. And in Alex, what's kind of neat about it is you can always be.
What section is this? 3 point.
This is like
What section is
3.2.
3.2. Okay, still okay. All right.
Yeah.
Is it 2 parts for 3.2? Because mine was the other one that you just finished.
What was the question?
Is it 2 parts of section 3.2? Because my 3.2 was the one.
There are multiple sections to each one. I mean, there's several topics in each one of those sections. All right, so I'm taking those out because I don't want to look at those now. So what's going to go here? Because we got the P already. And we got the not Q, which is right here. So what we're looking at, let's see if we can get a different color. We're looking at true and false, and we're using the OR rule. So as long as we have one true in there, then the OR is true for that combination. Here we got true or true. Well, you got one true, so that's true. Here's one that's two falses, so that's going to be a false. We got to have at least one true for true to be true, true compound statement to be true when it's an OR, and that's true. So then this here, that column right there, are the truth values for this statement here. In other words, under these conditions for P and Q, if P is true and Q is true, then the statement is true. If P is true and Q is false, it's also true. But if P is false and Q is true, it's false. False gives us a true. So that's what that tells us. And we'll see how it becomes important later. All right. So that's the way we do a truth table. All right, so let's go back over to the book. And we'll do more truth tables in the second hour. The second hour. But I want to talk about a couple of more things in the last 15 minutes. All right. So and thankfully you don't have to build these. Usually what they do in Alex, they'll give you, if they have one with 8, they'll give you like one row and then you apply the rules across that row. You don't have to have one with that many in it. All right. So this is basically just saying that without parentheses, that this is the pecking order. The biconditional is the most dominant. The conditional is the next most dominant. The conjunction and disjunction, third, tied. It's either one. And then negation is the least dominant. So what that essentially means is whichever one is the most dominant when you create a compound statement, it essentially says do me last. So if we have this statement here that P or Q arrow R, it essentially, just by dominance of connectives, forces that parentheses around the P or Q. It's forcing those two to bow down to the conditional statement because it's the most dominant. let's see. I want to mention a couple more things, and then we'll be able to break real quick. What happened? Okay. Oh, there we go. Where's the? Oh, there's the menu. And let me just talk this about equivalent statements. Statements that are equivalent, logically equivalent, have the same truth value. So that they're not showing how this was. Oh, I guess we are showing how it was done because they're only doing it in 2 steps for each one of these. But you'll notice on this, well, that these right here and these right here, this statement, if P then Q, and not P or Q, are logically equivalent because the truth values are exactly the same and in the same spot. All right. All right. So with De Morgan's laws, because De Morgan's laws are from last chapter, chapter 2. De Morgan's laws also hold here, but they're using the logic symbols. Let me go back through them and explain them again. But these are going to be very helpful for shortening your life work, because for this chapter, you really need to learn how to do the truth tables, but you don't want to do them unless you have to. And sometimes you can use De Morgan's laws to find out whether 2 statements are logically equivalent, or if we want to find the negation of a statement. But this is the way that it works. We looked at it over there in chapter 2, but not P or Q is logically equivalent to not P and not Q. Remember, the negation passes along to each of those 3, and it causes the sign to flip. That negation does. It gets passed on to the P and the Q, causes the or to flip to an and. Same thing happens here. If it starts out as an and, then the negation passes along to the P, to the Q, and the and becomes an or. So that's going to be very helpful. That's probably enough in this class for today. We'll start back. I want to see if anybody's gotten any questions. So, anybody got anything?
I do have a question. The 3.1 is due Friday?
All I can do is go in there and look, see, because I don't keep track of those dates. Those dates don't matter to me.
Okay.
Because let me get this past people, all right? Those are pacing dates. Alex creates those based upon the chapters that we cover. You can always still do that work. It never takes anything out of your path, and even until you master it. When it masters, it goes out of your path. But if you miss it on a future knowledge check, then it will adjust your score accordingly. So don't get, so caught up in that, because the material never disappears. But that sounds about right. All I can do is just go over there and look.
Okay, thank you.
But that sounds about right.
Naomi, mine says it's due tonight.
Well, it might be. And if that's the case, I might be able to adjust it for everybody. But just remember, people get all bent out of shape about those dates. And like I said, the Alex pacing dates can sometimes seem very, I guess you could say, arduous. But anyway, I'll see what I can do about that.
Okay, I'll see you in next class then. Thank you.
Okay.
Thank you.
All right. Anybody need anything? I'm going to shut it down and then I'll try to fix that before, check that date. Otherwise I'll forget and you'll have to remind me Thursday.